All right. So what we're going to do is I want to explain a little bit about how we use the combination of both nested arrays or nested loops and arrays to make something that handles a common tic-tac-toe board. So here's a general idea. You can actually have inside C++, you can have not only one array, but you can actually have an array of arrays. Kind of a weird concept, but here's how it kind of pans out. Let's imagine that we have a one-dimensional tic-tac-toe board. Okay? I'm going to make a one-dimensional tic-tac-toe board. Remember that this is, if I just get rid of everything else and just focus on this, here's my one-dimensional tic-tac-toe board, which is a very boring version of tic-tac-toe. Right? I effectively have 3 places in my tic-tac-toe board where I can put something. A tic-tac-toe board is a 3x3 grid, though. So actually in C++, you can say, hey, I have one row with 3 slots in it. I actually want 3 of those. Right? I want 3 of those rows. So if you want to declare essentially an array of those, you have to use another set of brackets. So here is my 3 characters, and then I have 3 of those arrays. If I were to break this apart, this is effectively me doing this. I can actually do this 3 times. This is my tic-tac-toe board. I have a board 1, 2, 3. And each of those boards is actually 3 slots in it. Look here. I have a 3 here, and a 3 here, and a 3 here. If you want to in C++, you can actually just make that an array as well. So now I have 3 of these. And remember how we can initialize them. We put stuff in curly braces separated by commas. So here's my curly braces. I'm going to separate them all by commas. And there is my tic-tac-toe board with 3 elements inside of it, separated by commas. Just to show you guys, you don't have to stop at 2. You can actually go more. You can go up to 3. This is what's called a 2-dimensional array. This is what would be effectively a 3-dimensional array.
I can't imagine that.
You can have as many of these as you want. Each one of these effectively says, I want an array of these, which is an array of these, which is an array of these. And it keeps going. So it doesn't stop at just 2. But you should pretty much only really concern yourself with 2. This is a very common thing to use when you're dealing with games like Tetris or like any Bejeweled clone. For instance, I have this game of Tetris here that I made in SFML. Look at the grids that are actually inside the board. You can actually see that it's made up of, 10 columns and like 21 or so rows. This is a multi-dimensional array. It has an array inside of it that has 10 columns and then 21 of those. Okay, exactly like tic-tac-toe, where tic-tac-toe is only 3 by 3. Tetris is effectively 10 by 21. Even the little bricks here, they're represented by the multi-dimensional array. If you didn't know, Tetris, every piece always has 4 blocks inside of it. No piece is bigger than 4 or has fewer than 4. Every piece has 4. So even this little block, there's actually every piece in this game is actually technically a 4 by 4 block with only some of them filled in. So these multidimensional arrays are useful for like any kind of game, like even games like strategy games, like let's say Fire Emblem, or like any like Final Fantasy Tactics, for instance. Anything where you have like a grid-based game, you're going to be dealing with this kind of structure pretty commonly. Okay? Because typically the way you want, let's say I want to put this blue piece right here. That's going to be column, let's see, 1, 2, 3, 4. It's going to be the fifth column. And if I count up from the bottom, it's going to be the second row from the bottom, right? So I need to know that I want to put a piece here on the second row, the third row, the fourth row, and the fifth row. So I'm actually indexing into this grid where I need those specific pieces. So this is what is represented here. If I were to say make a tic-tac-toe board, I could do that. I could say, hey, this is going to be 10 and 21 rows. I could effectively make a tic-tac-toe board myself with just these little characters if I wanted to, if I just make an empty board here. That number, that first number, is how many characters do I have per column, and the second number is going to be how many rows I have, right? When you're dealing with something like tic-tac-toe, it really doesn't matter which one you use as rows or columns. So I'm just going to go back to the way it was before. When you have a 3x3, you can use either one as a row or column, but this is how you actually declare. Notice here what we're actually using for the size, rows and columns. It says rows here. You can see actually where it declared the variable rows right above. It's declared as a constant int for rows. You're allowed to use a variable in here as long as you prove to C++ that that variable won't ever change. And the only way you can do that is by putting a const in front of it to say that, hey, this variable here is always going to be 3. It'll never change aside from 3. I'm going to give you guys this, by the way, so you don't have to worry about it, but I'm going to give you guys this program, and then I'm going to have you guys do a lab with this. You're effectively going to recreate the board by yourself, but I want to step through this code to show how it works. So I showed you guys how you can write a for loop to go over every element in an array. Well, you can use the same for loop idea to go over every element in the tic-tac-toe board as well. The only thing that you have to do is consider that you have one loop that goes over every row, and then you have to have another loop that goes over every column. Let me show you what this looks like here, just to start. How would I print out the middle X here onto the screen using a cout statement? How would I actually access that specific element? I have a variable called board, okay? And inside this variable called board, I have an index here inside square brackets that I need to fill in, and another one inside a second set of square brackets that I need to fill in. If you look, I'm going to use this first index to represent the row that I want to put it in, and the second index to represent the column that I want to print out. So if I want to print out the middle element here, which row and which column is that? What numbers do I put in here? 2 and 2, someone said? Remember, though, 2 and 2, arrays start at the index 0. So if I do 2 here, if I count the row, this is row 0. This is row 1. Row 2. What do I put here? It's actually 1, right? And a column here, 1. What if I want to print out the one right below the middle one here? What do I put here? 2 for the row and 1 for the column. Let me just print this out. It says 0. Okay. What if I want to print out this guy right here? Which row and column is he? 1 and 0. So the way I want you to think about it is this first number represents the row that you want, and the second number is going to represent the column that you want instead. Okay? So if I want to actually loop over and print out every value in the first row, I'm going to write a for loop that does that. I want to print out every column in the first row. So what do I put here? Every column in the first row. I want to print out 0x0. 0 here for the first row. And then here, what do I put?
I.
Every column, it's I. That's what my loop is looping over. Look at the word, I'm looping over every column here. So if I run this, this will print out at the top every single XOX, which matches XOX. Let me actually format this so it actually looks closer to what it looks like here. So you will see 0x0 at the top left corner. Okay? That matches every column in row 0. If I want to print out row 1, I just change this from 0 to 1, right? And there's my blank XX for row 1. I see how it's printed out up there, XX. And then I continue for row 2. Right? So, do you guys see a pattern here? This number I'm changing from 0 to 1 to 2. I have a variable called I here, which I can use. So if I had another variable, I could actually stick in here, then I could actually have it print out the entire board. What happens if I want to print out every column value? If I change this to rows, and let's say I want to print out every value in column 0, what would be here? Every value in column 0 I want to print out. What does this turn into? This turns into I. And this represents the column here. I'm going to print out every value here. So I want to see 0, blank space, and x. See how I have 0, blank space, and x here? If I want to print out column 1, I change this one. This second index represents the column that I want. This is XX0. So there's a pattern here too. I can get every row's value or every column's value based on where I put I. However, I can't seem to get both. I actually want to print out the whole board. So if I actually made a way to represent this index here with another variable, I can actually print out the whole thing. So if I take this entire loop and instead of printing out just 0, 1, or 2 here, if I made another loop with another variable name, but going over every column, I now have a variable called j that counts up to how many columns I have that I can use here. Why did I put this inside the loop here? What happens if I actually just do... There is a way to do this without doing a nested loop. Let me show you guys what that is first. How would I do this with just doing a separate loop? So if I just do 0, 1, 2. I could do this as well. This will print out for row 0, it'll print out column 0, 1, 2. And then it'll increment I, so I'll go to the next row instead. Zero, 1, 2. So I can actually print this out like this. So even if I don't use a separate loop, I can still get it printing out all of my columns here. Look at what I'm doing here. See how I have the board actually printed out here, 0x0, which matches the board up there. But notice again, what's the same? These are all the same exact lines of code here. The only difference is this value right here. So what I can do is I could write a loop like this, where I put the numbers in by hand, or I could recognize that there's a pattern here, and instead of writing out the numbers, I can use another loop. And replace this with the value of the loop. So let's do a reminder course again about how this inner loop works. So how many times is this statement going to get printed out total? If you look at, see how many cells I have in my tic-tac-toe board, this thing will get run 9 times total. That's because these two loops, which are, this one will loop 3 times, this one loops 3 times. However, this inside loop, it runs 3 times 3. So it runs 3 times again. So it's actually running 3 squared times, which means this statement runs 9 times total, which is correct because there's 9 empty spots in our grid. If you think back to our Tetris example, how many times do I actually print out the grid? I have 10 times 21, so 210 grid cells in Tetris. Okay. All right, so this is how you get columns and rows printed out. Something to keep in mind is that I'm looping through it 9 times. So there's my grid, which is x0, x0, blank space, xx, x00, all on one line. I actually want to separate this so it looks like there is a separate line here. So I'm going to do an end, ENDL. But look where I put this. I put it outside the inner loop. So this is going to run 3 times. Then it's going to print out an end line so it goes to the next space. So it's going to print out these 3, then hit return and go to the next row. So watch the output here. There's my output. Okay. All right. So now we know how to print out the board based on using a nested loop. So this is the loop you're always going to call to print out the board. You notice that it looks identical to the loop. If I zoom out the code here a little bit, there's one nested loop here at the top and another one at the bottom. Okay? And in between those is an assignment statement here. This is setting the board at row 0, row 1, column 0. So it's actually changing the board for this blank space right here. It's putting an X right here. That's what it's changing. So you can see here it's printing them out and then prints out the X right here. It adds that into the array. Look how it's actually assigning it. It's specifying the row index, then the column index, and then assigning a character here. And then we just print out the loop, print out the board again. Okay. So here's what I want you guys to do. I'm going to give you guys an empty board. So this board, I want it to be empty. And then here's the lab we're going to do. The board is going to be empty by default. And since you play tic-tac-toe, I want you to recreate the moves you made step by step. And I want you to print out the board after every move. So if you imagine here, this is printing out the board after some guy made a move here. I want you to make this board empty by deleting all of these. Right? Make the board empty. And I want you to recreate your moves by using this line, printing out the statement, and then reassigning, like playing back the moves by using an assignment operator for every move that you have. Okay. All right, so let me put this up on Zool so you guys can get started. This is going to be an individual project. It's going to be called Lab 2.
And what I want it to look like at the end is it should match exactly what your piece of paper or MS Paint looked like when you finish playing the game. Okay?